All right, May, what did you see here? What was it called? Right. So here, just real quickly, I don't want to make any assumptions here. I think everybody knows this one. So some of the questions that you're going to need to answer will rely on the fact that you can do this. So, for example, can we find this missing piece here? All right, you give it a shot, and we'll see if you remember your grade 8 math. Okay, so I've heard a lot of people call it out. You are correct if you said 4. Let me show you how you get it if you weren't sure. So the big side here, this longest side, is the C in that formula. It's always, the longest side is always the one in that formula that's by itself. Okay, so the way this would go is it would be 3 squared plus x squared is 5 squared. So that means 9 plus x squared is 25. So x squared is 16. Okay, so 4 is the number we were looking for. Now, just because it's recording and somebody might see it on the internet, there's actually plus and minus 4 because you square it, but we don't have negative sides on our triangles, so you don't need to worry about that. But just know that usually when you solve an equation, if it's squared, because this will come up for us later in our course, you got 2 answers, right? The negative would be squared, it'd be back to positive 16. Okay, so 4 is the missing side there. So what I'd like you to do is try the next 2 on your own and make sure that you can handle the Pythagorean theorem. Okay, so let me just put that little annotation in there. These are the 2 smaller sides, right? And this is the longest side. Do you guys know what we call that longest side? Yeah, I'm not sure how that's simpler, but anyway, probably something Greek. Now, when we twist these triangles around, if you're looking for the hypotenuse, one way that I find it easy to find it, because the triangles can always be, switched around, the longest is always straight across from 90 degrees. So if you're not sure which one it is, you can look for the 90 degree and go straight across to the hypotenuse. So for example, that is a hypotenuse because it's straight across from 90. So is that. Okay. So if I was to solve this, x squared is 8 squared plus 6 squared. So that'll be 64 plus 36. So x is 10 in this example. Okay. For the last one, I would like to see how you got your answers. You don't need to show every single step that I did, but I should have some indication how you did it. If nothing else, I mean, it would be okay if you omitted this part, but I should at least see what you started with before you get to your answer here, right? So if you didn't put those in, I'd probably still believe you, but I should know how you did it, right? So at least show me what equation you set up. This is grade 8 math, so I'm not going to expect a lot of work to be shown. But as we get more into the Math 11 stuff, I will expect you to show all your steps. But in this, you can skim it a bit. I'll just erase this in case you guys are trying to put the notes in there. Now, I wouldn't be doing my job as a math teacher if I didn't tell you that this is a very famous, these are very famous numbers. Anybody know what they are? They're squares, yeah, those are famous numbers, but these are very particularly famous. You do know this?
No, she Da Vinci.
Is it? I don't know if Da Vinci... Pi? Anyways, the girl who what? Oh, is it? Okay. Well, this is Pythagorean triples. Is that what it was? Okay, there we go. Another book for me to read then. The 3 numbers are a Pythagorean triple because they're integers that can fit into Pythagoras relationship here. So for example, if I wanted to give you a triple, this is a triple here, 3, 4, and 5. There's another one here, 6, 8, and 10. There's another triple here, which is 5, 12, and 13. Yeah, those three numbers go directly into Pythagoras' formula. Now, anybody heard of Fermat? Anybody heard that guy's name before?
What?
He is, okay. Well, Fermat, you guys actually, you're going to find this shocking, but back in the day when, the 1600s, I guess before they had TV and Facebook, it was actually very prestigious to do mathematics because it showed you had education and that showed you had money. So Fermat was actually a lawyer. He wasn't a he was a mathematician, but his actual job was he was a lawyer and that was his training. But he did a lot of math to show the rest of the world just how awesome he was. So anyway, one of the things he did, we looked at this and he said, oh, well, I've managed to figure out that you can't do this little trick that we just found if you have an equation like this. It only works when n is less than or equal to 2. So for example, there's no Pythagorean relationship that goes like this. It won't work for any number that's bigger than 2. But the thing is, he said, I don't have room in my margin to write the proof out for you. This is kind of interesting because you guys just finished a unit on proofs. He said he had a proof, but it was too big to fit in the margin where he wrote this down. And it sat in his book for about 400 years, and nobody could figure out this proof. And there's actually a guy who did it just recently from Princeton. And I'm going to show you this clip. It'll give you a little bit of insight into kind of how mathematicians are. And I'm going to pause it so it's not on the YouTube video because that video on a video, it tends to goof things up. So in case you see it at home, this was the video just in case you wanted to go watch it again. But yeah, well, it's only a minute of your life and it's not that bad. Okay, the other thing that we needed to talk about in trig was here. It was naming sides of a triangle. And we just talked about across from the 90 degrees, you get a hypotenuse. Yeah, that's right. So the one closest to the angle, it's actually the one that's touching the angle, right? It has to touch to be adjacent. So that one we call the adjacent side. And in this, they change in the two pictures because you see one angle's on top, then in the other picture, excuse me, the angle's on the bottom here. So the adjacent side is here. I guess I'll have to write it like this. But in this triangle, the adjacent side is there. Adjacent. Now, the last side, which you probably remember, is the opposite, and it's the one opposite or directly across from the angle. So this one is opposite. As is this one here. It goes directly across from the angle. So when you read that if you read that in your textbook, when they talk about an angle being opposite, they mean it's straight across from the angle. Question, yeah? How do you figure that out if it's an equilateral triangle? If it's an equilateral triangle, yeah. The sides would be equal, right? Yeah, so there's no hypotenuse for that. That's a good point. We're talking about right triangles right now. So we'll always have a 90 degree in these triangles. So yeah, we're only going to have adjacent and opposite sides when we don't have 90 degrees anymore because we can't pick it's not going to work the same way. Good question. Okay, so let's just, we won't do all of them, but let's pick a couple here. I'll number them and you give me, all right, somebody pick a number for me. 4. Well, 7's not up there. 3, okay. Triangle number 3, which side is the opposite side? Like the bottom here?
No, the top.
Okay. Yeah, so this side is the opposite. So I'm just going to put an O for opposite. Which side is the hypotenuse? Right, so you go straight across from 90. And then that means the adjacent is the one left over. Okay, let's just try one more triangle. So 1, 2, 4, 4. Okay. So 4, somebody tell me which one's the... Here, this will make it easier for you to tell me. Let's call this 1, 2, and 3. Which side is the opposite?
2.
Oh, you guys are pros. Good Math 9 teachers you must have had. What about which one's the hypotenuse? 1. Good. And then that leaves us with an adjacent side right against the angle. Okay, so I know it seems silly, but I got to make sure you guys know that before we can start talking about the trig ratios. So these ones, you probably remember this. It's your favorite math saying. Yeah, that's the one. Yeah, everybody seems to know it. There's actually one in grade 12 that I teach too, and it's Choshakao. So anyways, just something for you to look forward to. So the sign, remember what this SOHCAHTOA is a weird phrase, but it's to help you remember that the sine is the opposite over the hypotenuse. So that's how the acronym works, right? And that the cosine is the adjacent over the hypotenuse. And that the tangent is the opposite over the adjacent. Okay, so I'll just give you a minute if you're copying that down. So all I want to do now is make sure you guys remember how to use these ratios. So again, same thing. I'm just going to number them and we'll pick a couple to do. Okay, 1, 2, 3, 4, 5, 6. You at least have to write down the ones that we're doing as a class. So 6 was asked for first. So I'll do 6 for you. Angle C is this one. So here's what I'm looking for. And it says I'm looking for angle C, which would be this one here. So can anybody, I'll just throw it out there. Does anybody know what the ratio is for sine of C?
What? 32 over 32 over 24.
Yeah, it's going to be opposite over hypotenuse. So here's the opposite, and here's the hypotenuse. So sine C is 32 over 40. Now remember, when you do your work, you may also find it in lowest terms. And in lowest terms, we would see that we can take the 8 out of both. That's 32 out of 40. Does it not look like it? Here, no, we're not finding the angles yet. This is still, we're warming up to it. That's coming later. Okay, how about another number then? Number 1, okay. See if you can figure out the sine of x, and then I will come back and show you guys how it's done, and hopefully we're all on the same page. So I've heard it murmured quite a few times. Let's see, what did you get for triangle number 1? Sine of x is 0.6 as a decimal, but what's the fraction? That's easier for people to see. Yeah, 18 over 30. So here's the opposite side right there, and here's the hypotenuse. So the sine of x is opposite over hypotenuse. And you can also reduce this. It's a good habit, yeah. It's a good habit if you if you can to reduce those fractions and get in that habit. So yeah, Logan? So you didn't know which one the angle was for x? Oh yeah, it would have to be labeled for me to ask you for which angle you're dealing with. Okay? Later we'll talk about how the sides are labeled. For example, this would be labeled lowercase y. It's paired up with angle y straight across. This would be lowercase z, and this would be lowercase x. The ones directly across line up. But we'll talk more about that. That's the only time you wouldn't have them labeled. We will, yeah. So let's do one last one here. So 2, 3, 4, 5. Okay, 4. So we're going to pick number 4, and we'll end off here. So let's see if you can do it. 30 seconds. Ready? 30 seconds. You can do it. 30 seconds. Number 4. Go. All right. Let's see. Hands up. You have an answer. You don't necessarily need to be right, but let's see. Do you think you have an answer for this one? Okay. So let's we'll work it out here. Cosine is what? What is the ratio for cosine? Adjacent over hypotenuse. So here is angle C. This is my adjacent side, and this is my hypotenuse. So the cosine of C is going to be 20 out of 29. Okay? So let me just tell you one thing here. You will need to be able to do this. If you cannot do it, you need to come for tutorial with me after school, okay? Hopefully it's quick enough for you, but if not, that's fine. It is a skill you need to know, though. So there's one other button. There's one other button in your calculator that we haven't talked about yet, and that's finding out what the angles are. And we're going to need to use one of these buttons. So for me, it's going to look different on everybody's calculator. I'll give you a minute, but for me, it's these ones right here. See that sine -1, cosine -1, tangent -1? Those are the inverse functions, okay? So what I want you to do, I'll give you a minute. Just make sure you can find those buttons on your calculator, okay? So again, I don't want to walk us through every single question here. Let's just try a couple. So what I'm going to do this time, I'm not going to have you guys make a decision here. I'm going to have you do 3. I'm going to come around and see how you're doing. I'm going to do all 6 for you because I'll go through them real quick, but I'm going to give you about, I don't know, let's say 3 minutes, 5 minutes to do 3 of them. Any 3 you like, pick 3 to do on your own. So let's take a look at 3 just to make sure you're on the right track. What you're going to do is if this is the angle, you want to think about what sides you have. I have the opposite side and I have the hypotenuse. So sometimes if you're handy with this, you can probably just go and find the answer. But if you're like, I don't know what to do next, this is where I tell all my grade 9s when I teach them to go to is actually go on SOHCAHTOA and say I have an opposite, I have a hypotenuse. So who wins out of all those? Yeah, so sine is the one I'm going to use. So the way I would find this in my calculator is the sine inverse of 26 over 37, and that'll give me the angle. So obviously my calculator is different than yours. I'll move it out of the way. Not all of you have the same one, but it'll look similar on your screen. Okay, so I'll show you. In my calculator, I would go like this. 1 second, I'll take questions in a second. First, you want to make sure you're in the right mode. You might notice I'm in radian mode. I should be in degrees for our class. So make sure yours, it should say like DEG at the top or D or something like that. Now what I'm going to do is I'm going to go inverse sine of, what was it, 26 over, 26 over, yeah, it's because I have clumsy fingers and I pushed the wrong button, over 37. No, it won't work that way, but. So you should get 44.6 for the degrees here, okay? So if you're on the right track, it'd be 44.6 degrees. So I'll let you keep going, but you got to pick 2 more. I'll go through the rest of them in a minute. So let's walk through each of them, but I'm going to walk through fairly quickly, okay? So for the first one, the sides you have are the opposite and the hypotenuse. So I'm going to use the inverse sine of 50 over 52. That means I'll have 74 degrees, 74.1. For number 2, I have the adjacent side and the hypotenuse. So that means I'm going to be working with cosine. So again, adjacent and hypotenuse, it's going to be the cosine that I use. So cosine inverse, and it's 46 over 59. So this time, in my calculator, I'll get 46 out of 59, 38.8. Okay. And for this one here, I have the opposite and I have the adjacent sides. So I'm going to be using tangent now. I have opposite and adjacent. So tangent inverse of 6 over 23. And let's see now. Inverse of 6 out of 23. So 14.62. So 14.6. In this situation, I'm dealing with the adjacent and the hypotenuse. So it means I'm working with cosine. Cosine inverse is 33 out of 52. So the angle is 50.6. Okay, and then the last one, again, I have opposite and adjacent, so I'm going to be using the inverse tangent of 6 out of 15. And that's 21.8. Okay, so hands up if you got at least 2 out of 3 of your angles correct. Good stuff, okay. Now, a good question was asked, how do you know when to use these ones or when to use your sine, cosine? Yeah, so what you have to think about here is what you want and what you get. So in here, what I do is what I'm going to use is a ratio, and it's going to give me back an angle. In these buttons, regular sine, cosine, and tangent, I put in an angle, and it gives me back the ratio. So what you have to ask yourself is, do I want an angle or do I want a ratio? Or maybe in reverse, you say, do I have a ratio or do I have an angle? But that's how you know which button you're going to be working with. The inverse ones, they always take the ratio inside of their brackets, and they give you the angle that would have come out of that triangle. Whereas the other sine, cosine, and tangent, the normal ones, those you give it an angle and it tells you what the ratio of the sides would be. Okay, so maybe, does people need a minute here? Should I pause it? Okay, so unfortunately, if you didn't quite get it, maybe grab it from your neighbor or bring it back up on YouTube tonight. So here's another thing that you would have done was find the missing sides. That's the last thing you would have had to do probably in your grade 9 or 10 math class. I'll zoom out just a little bit here so you can see them. This time we'll do 2 of them. So here's 1, 2, 3, 4. I'm going to do the first one with you, and then you can pick 2 of the other ones to do. So hold on. What number do you want me to work with? 3? Okay. So to do number 3, I need to find this missing side here. So I'm going to set this up the same way I do all my questions with right angle triangles. I need to write down one of the SOHCAHTOAs. Which SOHCAHTOA do you think I'm going to use? Well, let's figure this out. Here's my angle. That's the opposite. Which side is this? Okay, so now it should be clear to you which ratio am I going to use? Sine, right? So I'm using SO out of SOHCAHTOA. So the expression I get is the sine, and remember, like we just said, if it's regular sine, it takes an angle. So sine of 21 is x over 10. Now we rearrange this. 10 times the sine of 21 is x. And let's see here. So 10 times the sine of 21 is 3.6. So I will do the other 3 very rapidly, but I would like you to spend the next 5 minutes with your neighbor working out any 2 you want. Okay, make sure you and your neighbor agree. Okay, so let's see how you did. In the first question, we'll get to number 2 in just a second. Maybe this will answer part of your question for number 2, but the first question, you always got to start by saying, what ratio in SOHCAHTOA am I using? Whenever you have a right angle, that's what you're going to be working with. So the sides I have are opposite and the hypotenuse. So this is a SOHCAHTOA question again. This is the SO part of it. So what I have is sine of 70 degrees is 20 over x. Now if I rearrange this, then my answer will be 20 over the sine of 70. How many people would like me to review how I did that? Okay, let's, in case you're rusty, let's start the process here. What you need to ask yourself, I know there's a lot of a discussion because there's a lot of different questions we're doing, but let's focus on one for now, okay? So what I'm working with here is I want to get this x. My goal is to get the x over here to this side of the equation on the top. So to do that, what I need to do is get it off of the bottom. Now, there's a division here, right? So because I'm dividing, the way I can get rid of it is through multiplication. So if I multiplied this by x on the top, now the equation is changed unless I do the same thing to the other side. So if I multiply by x on one side, I got to multiply on the other. So here's what I get on my next step then. X sine 70 equals 20. Because there's an x here and an x there, so they're gone. It's like 5 divided by 5, that's 1. 9 divided by 9, it's 1. So 1 is not, multiply by 1, nothing happens. Okay, the next step, when I look at this, I want to get rid of this thing here now, right? If I want to get rid of that, what's the operation that's holding it together? You have the solution. What's the operation that's holding it together? Multiplication is holding it together, so dividing it is going to get rid of it. So divide it out. But you have to do the other side as well, or you've changed the equation. So that means these two things would just be a 1. So I'd end up with x equals 20 over sine of 70. Same as what I had here. Okay? Now, some of you might have known about the shortcut. Shortcuts are always dangerous if you're doing it and you have no idea how it works. But the shortcut is cross multiplication. I'll show you how that works just in case you haven't seen it. But if this is sine of 70 is 20 over x, whenever you have, I'm just going to put divide by 1 so nothing happens. But whenever you have two fractions and nothing else, okay, this shortcut only works when there are two fractions. You can do what your teacher's probably told you is to cross multiply. That means these are the paths that they can travel along. So if you want to move things, you can move them along those diagonals and the equation will be safely, equivalent. So sine of 70 could go to the bottom right or x could go to the top left. That's it. They can't go anywhere else. 20 could go to the top right or down to the bottom left. 1 could go up or down. As long as you move on those diagonals, then you'd be okay. But be careful because that only works in this one instance where there's two fractions right there on either side of the equation. Okay? All right, so I'm going to try number 2 now. I guess I'll have to do it above. So for number 2, the angles here, this is opposite, and the side I have here is adjacent. So this is going to be a TOA, which is tangent. Okay? So the equation will say tangent of 69 degrees is the opposite over the adjacent. Now, again, if you want to cross multiply using that shortcut that I just showed you, that's the direction I can move those two things. So I would have x equals 19 over tangent of 69. Okay, and let me just work that out. So it's 19 divided by the tangent of 69. Oops.
Is it back tangent?
19 divided by tangent of 69. So I get 7.3. And I guess, sorry, I didn't do the first one. I wrote the equation there. I'll do the first one. That would be 20 divided by the sine of 70, which is 21.3. Yeah, I'll usually if I don't say 2 decimals is enough, but if I want more, I'll ask for it. 1 decimal usually okay too, but I'll be more specific if I want a lot of accuracy, okay? Now, so let's try the last one here. You walk me through it now. Which ratio do I have to pick out of this triangle for number 4? Yeah, I have an opposite and I have a hypotenuse. This is a so question. So can somebody tell me what does the equation sound like if you were to read it? Sine 34 is x over 11. Yeah, that's right. And again, this is the pathway these things could move on. So the 11 can go up to the top. I would have 11 sine 34 is equal to x. So let's figure out what that value is. 11 times the sine of 34. So 6.2. Do people need a minute there? Okay, I'll give you 30 seconds. All right, so let's,
No.
I know, just when you thought it was only triangles, right? You had to go and throw word problems in.
Trees leaning on a house. Like the rain, like the
All right. So is your excitement for trig still there? Okay. So I'm going to walk you through these. I'm going to draw the pictures, but I'd like you to find the value, okay? So in this case, it says a child is 3 feet tall. So here's my 3 foot tall child. And let's say the angle of elevation, and it's going up to the,
Write this down.
yeah. So let's say it's going up like this. And we know that 50 feet of cord has gone out. So I guess they have a fancy kite that as the string goes out, it tells them how far out it is. And it tells us that the angle in there is 40 degrees. And let's see here. Okay, so it wants to know how tall is this, sorry, how high up is the kite? So in your picture, you know this person here is 3 feet tall. Yeah, so you'd have 3 feet there, and we'll call this h for height. So your turn now. Go through and see if you can figure out how high up the kite is in the air. Okay, so if you did this one correctly, what you're looking at here is the opposite side and the hypotenuse. So this is a sine problem. So that means the height is 50 times the sine of 40 degrees. So 50,
It's 32.
I'm sure it is, but let me just put it in here. So it's 32.1. That's right. So the kite
And you can do python.
is 35.1 feet high. Why 35.1? Right. Okay, see if you can do the next one here. This one may be a little more straightforward because you don't need to worry about how high up the kite is being held. A student stands 20 feet from the base of an apartment building and measures the angle of elevation of 65 degrees to the top. How tall is the building? There. All right, so you got an apartment building here. Yeah, you can, doesn't matter which way you're facing. And then you got somebody standing here. And let's say the angle of elevation is 65 degrees. And we know they are 20 feet away. So what we want to know is how tall is the building? So this is what we're looking for. Whoops, that's a terrible, let me try that again. That's better.
What is this one called?
So I'm going to call it h for height. What is that? I don't know, it's just a brace for all I know. So which ratio do I use this time? Opposite and adjacent is correct. This is the adjacent. This is the opposite side. So I'm going to use Yeah, tan. And it's going to be opposite over adjacent. So the height of this building is 20 times the tangent of 65 degrees.
I got it too. 0.8. 43 then. Do you round it?
42.9.
43.
And we're in feet. So I don't know if you guys have seen those guys standing with the tripods on the side of the road that do those measurements, the surveyors. Yeah, they have, I highly doubt they do those calculations by hand, but they take the measurements by hand and those angles of elevation and depression. That's what the surveyors are doing with those tripods when they're on the side of the road. So something similar.
Oh goodness, this is too much. We're not doing that.
What's that? You could, with some of this knowledge, do surveying, yeah. Okay, you don't need to write I'm going to read it out to you. The first thing I want you to do is draw a picture. So all I want you to do is draw the picture with me so the information is in the problem there. So it says, a tree is to be transported to a new location. The tree is held vertical by 2 guy wires of unequal length on opposite sides. So if this were me, now my brain is full, I would want a picture here so that I could put that into my page and not have to read it again. So since trees are, well, I guess they're not all green, but. I don't know if I have brown. I'm sure there's brown some, well, maybe more colors.
Look at the bottom. That's all green.
Okay, anyways. So there's 2 guy wires. So one would be like this, and then the other one is holding it like this. Well, even if you don't know what a guy wire is, it's holding it from opposite sides of the tree, and you don't really hold a tree up very well if you hold it from the bottom, right? You have to steady it from the top. Well, yeah, anyway, but let's just go with what we have. One of the wires makes an angle of 48 degrees. The other wire is 12 meters long. So let's put that information down. One angle is 48 degrees. The other wire is 12 meters long and makes an angle of 56 degrees. And it says both wires are attached 3 meters from the top. So I guess my tree is a little bit taller than this.
That's 3 meters high more.
Yeah, so 3 extra meters there. So we want to determine the height of the tree, and that's probably all the time we're going to have to finish this. But you may want to go and take a look at trying the other questions on your own, but I think we're going to run out of time after we find the height. So let's give this a try quickly and see if we can do it. How could you quickly find the height of the tree? Well, first of all, you have to have a triangle in your problem or you're not going to get very far. So in fact, here there's 2 triangles that you want to work with. So the 2 triangles you want to work with are those 2. And the height of the triangle is this piece here. The pieces I'm looking for, this is the hypotenuse, and this is the opposite. So again, I have a sign question to work on. So let's figure out what that is for the height of the tree. So 12 times the sine of 56, and I get we'll call it 9.95. But that's only the height up to here. It doesn't go all the way. I still have these 3 meters. So the height of the tree, right, 12.95 meters.